Okay, so in this video, we're going to go through the answer for question 8 because there is a bit of misconception as to why the correct answer is represented by graph C and not graph B. So what we're first going to do is understand how a complex number is represented because, of course, we are working with complex numbers for this question if we are looking at an Argand plane. So a complex number is represented by Z is equal to A plus BI. Now, the important thing to note about how complex numbers are represented is that A is always our real component and B is always our imaginary component. And it's our imaginary component because it is with this I. But anytime that a complex number is represented, your imaginary component is always represented by B. So we want to find W, where W is equal to I multiplied by the conjugate of Z. Now, an important thing to note about this form is that it can also be represented by A minus negative BI, because two negatives make a positive. So W is equal to I multiplied by the conjugate of Z. And as we know, the conjugate is when we change the symbol in the middle, because we've got a addition symbol here, it's going to become a subtraction symbol. So W is equal to I multiplied by A minus BI. Now, you'll note that I've used this particular form, and it wouldn't even matter if I use this form here as well, because if we change this symbol to a positive, our B would still be a negative value. So we're just going to expand out I. So we're going to have AI minus BI squared. And as we know, I squared is equal to negative 1, and negative 1 multiplied by negative B is equal to positive. So W is equal to AI plus B. Now this can also be represented as AI minus negative B. Now again, the important thing to remember is that A is our real component and will always be our real component, and B is our imaginary component and will always be our imaginary component. So we need to look for an Argand plane that represents a position where our real value is positive and our imaginary component is negative. So our imaginary component is negative here, but our real component is negative, so it can't be A. Now in B, which is what you would think it usually would be, because you get up to this point, and when you get up to this point, you go, okay, this is the real component, this is the imaginary component. They're both positive, it has to be this one. But when we represent our complex number in this way, it is not represented as both values being positive. So therefore, it can't be B either. Now let's look at D. So again, our real component has to be positive and our imaginary component has to be negative. And from this, our real component is not positive, it's negative, but our imaginary component is negative. So it can't be D because it doesn't satisfy both terms. Now, if we look at C, our real component here is represented as a positive value, and our imaginary component is represented as a negative value. So therefore, the answer is C, because our real component, which is represented by A, is positive, and our imaginary component represented by B is negative.